not even sure I'm a data scientist, so and I'm certainly not really a machine learning person, although I use machine learning in my spare time, as I think most of us now do. But I will tell you, I think, a little bit about the evolution of our lab and kind of what we do, and a lot of demos, and I hope you find them fun. And so the theme is finding and telling stories at internet scale. So talk has 3 or 4 parts: contextual search to editorial judgment is our first part. So the problem that we originally started with, and my research partner Chris Hammond and I, is that this is a dialogue box for a particular kind of dialogue that you have with a machine. And so, I like to say that it is easier for a rich man to get into heaven than it is for you to get the thoughts out of your head through the eye of this needle and out into the world and get back an answer. And the fact that it works a lot of the time is actually a miracle when you think about it, because it's actually a phenomenally narrow bandwidth with which to communicate with the world. And there's a lot of world out there and a lot of thoughts in your head, and you typically will type 1 to 3 words in here, and you'll get back something that's useful for you, which is absolutely amazing. And it actually works because, for the most part, people want the same thing. And if they didn't, actually, it wouldn't work at all. But we got interested in the idea of what would it need to transcend this kind of conversation. And we thought, first of all, what's lacking from this conversation is any notion of context. So the first solution that we built, and by we I mean actually our CBJ Budsick, was a system called Watson, which was a system that actually would automatically go out and find information for you relevant to, this is about 15 or more years ago, find information that was relevant for a document that you were reading or writing. Here you're writing a PowerPoint on jazz and American culture, and off to the right there is a typical kind of search results page, and it's actually building things to actually return to you that are relevant to the thing that you're writing here. The idea being that this is kind of an automatic researcher. It's finding stuff based on what you're reading right now and showing it to you. The first thing I learned from this program is never call a program something that a much more important and famous program will be called later. I'm not going to make that mistake again, but, or I should say, Chris won't either. So this is a very cool system, and we actually decided we'd start a company. Here's how it works. It does some context analysis, which is sort of statistical and heuristic analysis of the text you're looking at, automatically forms queries, manages those queries, filters and ranks the results, and then presents them back to you. And this machine actually was this machine was actually fast. No, I don't do mobile. This thing is fast, it was automatic, and it was better than human. And by better than human, I mean that if we gave you a text and asked you to formulate queries that would return results relevant to that text, and then we executed those queries, and then we actually asked this program to do the same thing with that text, and then gave all the results back to you mixed up, you would actually judge the results from the program to be, in general, more on point than the results from the query that you had written yourself. So we thought this was fantastic, and we started the company. And I'm not going to say the company it was not a debacle, but it was not a raging success either. And one of the reasons why it was not a raging success was what we started to hear from people is that the results that were coming back were kind of, they were on point, but they were more of the same. They weren't necessarily useful, and we realized that we were making the same mistake that actually information retrieval makes in general, which is to confuse, to take similarity as a proxy for relevance and to confuse the two. So the thing is that if you think about it for a second, the most similar document to a document you already have in your hands is another copy of that document. And that shows that, in the limit, similarity is not really a proxy for relevance. It has to be the case that in order to be relevant, it's going to be similar in certain respects and dissimilar in other respects. So our system actually at that time relied on noise and the size of the internet to bring back stuff that might be dissimilar and interesting. Now, if I were a statistically minded person, I would start to think about, like, what percentage of overlap do I look for, and I'd be looking for the golden donut. And there are a lot of people who do that kind of work. Jaime Carbonell at Carnegie Mellon has done that kind of work, for example. But I don't actually think that way. And the way I begin to think of it is that this is an editorial judgment. In other words, deciding what to show you is the kind of work that if this thing had been put together by a human being would be a human task using editorial judgment to say what information should this person be seeing, and that judgment is going to be based on It's going to be a deliberate mechanism. It should hopefully be an understandable mechanism to you, something that you can actually get, and I think actually a semantic mechanism. What I mean by that is that there should be specific dimensions of similarity and dissimilarity that are relevant that you could think about that would actually lead to sort of priming the pump and getting back the kinds of things that would matter to you. Now, what would that mean? So here's a similar system that we built for video called Beyond Broadcast. So it would actually, when we're looking at video, automatically bring back stuff that was relevant to you. Here's a case where it's looking at a show that Alton Brown used to do on the Food Network, which was a great show, actually, much better than anything he does now. It was a kind of a food chemistry show, actually, about how cooking works. And it was actually very informative and exciting. And here what we've done is that this is a show that where Alton Brown is telling you about a variety of Midwestern gourmet treats. In this case, I believe it's a corn dog. So we're talking about corn dogs, and we have here a bunch of things like we go out and find a definition of a corn dog in Wikipedia, or here we have some recipes from the Food Network, and so we've kind of put together this page for you automatically that has what we think are the right kinds of things. It's looking for stuff about Alton or from Alton because he's a star, stuff that's relevant in general, stuff that's about recipes. So we've begun to categorize the kinds of things we're looking for. I want to focus on recipes for a second. So if you type lasagna recipe into a search engine, you're going to get somewhere north of 5 million hits. There are at least 5 million lasagna recipes on the web. So nobody needs 5 million lasagna recipes. And if I'm showing you a lasagna recipe already, you certainly don't need 5 million more, okay? So I want us to think for a second about what is it that I should show you if I'm showing you a lasagna recipe. Like, what's another thing I should show you? If I'm going to show you another recipe, what should it be? So that's the accoutrements concept. Okay, so we're thinking now a graduate student feast, slightly upscale from pizza. It's going to be lasagna, garlic bread, Caesar salad, and Chianti. I believe I had that meal many times when I sat where you're sitting now, many of you. It was fabulous, okay? It is a good meal to have. But so garlic bread is good. What if I were going to show you another lasagna recipe? Should I show you the most similar lasagna recipe? What should I show you?
The one rated the best.
The one that's rated the best? Okay. So that's a dimension of difference. Show me a recipe that's like this one but has the highest rating you can find. That's an excellent difference. What else?
Different spices.
Different spices. What else? Vegetarian. Okay, so now we're cooking. I mean, we can get somewhere. These are dimensions that actually matter, either for products in general or consumables, let's say, or for recipes specifically. For example, I can look for the vegetarian version of this. I can look for the vegan version. I can look for the low salt, low cal, low carb. I don't know what that would be for lasagna, but you could probably try to do it. I could do classic lasagna. I could do quick and easy lasagna for a crowd. Blah, 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 blah. Everybody with me on this? So these are all dimensions of cooking. And it's, in fact, if you go to a search engine like Google, when you type in lasagna recipe space L, you'll see low fat, low salt, low cal completions, because these are queries that people have asked for. Now the thing is, what Google's doing there is it's mining the things that ordinary people have asked for. A cookbook editor might actually know what would be the right thing to show you. What are the dimensions that matter? And so the idea here is that the dimensions that matter are take the recipe, and the differences are these kind of differences that matter to food: vegetarian, gluten-free, low cal, etc. Highly ranked. Okay. So those are kind of the dimensions that matter for food. Of course, they aren't the dimensions that matter for news. Highly ranked might matter for news. The other ones will not matter for news. Like low salt news is not really a category. Okay. For news, the dimensions of variation are going to be different. Here's a system that was built by my student Jiawei Liu, now at Google. This was kind of an analogy machine. So here's this thing where I'm giving it the system a story about Oracle trying to buy Oracle tried to buy MySQL once. Okay, and actually you give it a story about Oracle trying to buy MySQL, and if we gave it to the previous program, it would come back with a million other stories about Oracle trying to buy MySQL. This story comes back with things like IBM. Well, let's go to the next page. IBM trying to find a company called Blue Code. Okay, And so the idea is here what we have is kind of a tech giant trying to buy a little open source software company is the actual theme. But the particular tech giant and the particular open source software company, little open source software company, is different. Does that make sense? And so that's what this system did. It found similar cases involving distinct entities. Here's another example. Here's a story about Israel's use of cluster bombs in the 2006 Lebanon War. And if you again gave that to the previous one, it would find 20 million other articles about Israel's use of cluster bombs in the 2006 Lebanon War. This system finds stories about U.S. use of cluster bombs in Iraq, NATO use of cluster bombs in the Balkans and Afghanistan. In other words, different entities doing a similar activity in a different situation. So again, it's kind of about the dimension of variation here is like different entities, different situations. Here's another system Joway built called Local Savvy. What's a dimension of news that matters? Here's a story from a while ago, but it's always the same. Putin visiting Iran, so this could be yesterday or tomorrow, but this was actually 10 years ago or so. So Putin visiting Iran, and if we have a story about Putin visiting Iran, and I give this to our system, maybe it'll say like, sort of a simple system, it'll say things like, hey, I can show you a story from the New York Times about Putin visiting Iran. I can show you a story from the Wall Street Journal about Putin visiting Iran, from CNN. If I'm really daring, I'll show you a story from The Guardian about Putin visiting Iran. Okay? If you really want a different point of view about Putin visiting Iran, what would be a good place to go look for it? I'm sorry? Well, absolutely. In other words, you want to go to either Russia or Iran to find out what they thought about Putin visiting Iran. Okay? And that's what this program does. It actually says take the story, or actually take the terms associated with the story and search for stories that are like it, that are actually in Iranian news sources in this instance, okay, as well as Russian news sources. So it goes through and tries to identify the stakeholders associated with the story. It tries to find publication venues relevant to those things, and then it searches in those specifically instead of in, here's an Iranian news source. That's exactly right. Here's another thing that she built. She was pretty prolific. She's doing really well. I just saw her out there. She's like, she was able to spend 20 minutes at lunch with me, because that was exactly how much time we had. But anyway, the other thing about having students go to Google is that they can never really tell you what they're doing, or hardly ever. It's not the most secretive company in the world. I mean, Apple is the most, or maybe Facebook or Amazon are more secretive, but it's actually pretty weird. You have discussions with people, and it's like, well, what are you working on? It's like, search quality. Well, what are you doing in search quality? I can't tell you that. I had a conversation with a former student who's out there now who's working in machine intelligence, and I said, well, how many people are working in that unit at Google now? He said, I can't tell you that. But I was able to guess after talking to him. It appears to be the case that about 10% of the company is working on it. So that's, they have about 60,000 people. So they have probably at least 6,000 people working on it. I know, isn't that amazing? Astonishing. That's my guess, though. He didn't tell me that. Okay? This system actually, this raises, by the way, an interesting question of how do you compete with that? And we can talk about that later. But the answer is, and I'll tell you what my answer is. My answer is don't go where they're going. Whatever direction they're going in, go in a different direction. Okay? Okay, because you're not going to compete with people that have 6,000 developers. Here's a system that looks at news stories from the perspective of what I got this wonderful 50-cent word as a scheme is from the point of view of different dimensions of knowledge, you might say. In other words, I wanted this story from an artistic point of view, a business point of view, an education point of view, a legal point of view, etc. So here's a story which was here's an evergreen story. The European Union going after an American tech giant for antitrust violation. At the time that we did this story, it was Intel. Later on, it was somebody else. Right now, I believe it's Google. It doesn't really matter. It's always going to be that story. And in this case, we have a discussion of that story from a tech point of view, and here we have a discussion of that story from a legal point of view. And we can talk about why this works. Actually, the technical challenge here is I don't want to have to actually download all these blocks to do the text analysis because that's slow. So the question became, could we actually do a decent job of identifying the point of view just by looking at the snippets that come back from the search engine? And the answer is yes. You can do a decent job just with the snippets. So that was really kind of the trick there. Here's a system that was done by my student, Francisco Iacobelli, not at Google. Uh, and what this system did is it found sort of additional information relevant to a story that's not in that story. So, for example, here's a story about the accident in the Gulf of Mexico a couple of years ago when this British petroleum well was spewing oil out. And what this program does is it does things like it looks for additional. So if you're going to find new information, that's a very challenging problem. What does it mean to say information that's new that's not in the story? So a lot of times what we're trying to find is sort of what I would call a cheap syntactic proxy. What's a cheap syntactic proxy that's computable easily for new? In this case, it's new people, so new named entities. For example, the American Petroleum Institute and its director, Jack Gerard, is not mentioned in this story, but he's mentioned in this story, which is on the same topic, so we're going to bring that information and show it to you. New numbers, new data, in other words. So here, for example, we have how much oil the four vessels have to be able to hold that they're going to be using to try and hold the oil that they're getting out of this thing before they cap it. And new quotes, okay? The hope is that we can slowly turn off the valves, close the cap completely, and then test pressure to see how the well performed in Fat Al, the government's point out the best instead on CBS as the early show. Okay, so it looks for these little syntactic things that are likely to be new information because they're not in the original story that you were looking at, and it brings them back to you and shows them through automatically. Are there any questions about this, by the way? This has nothing to do with machine learning. I hope that's okay. We'll get to a little machine learning. So we actually ended up generalizing this. I mean, the goal of computer science at some level is once you do a thing like this, is that, and here's a path for AI that I think is a very doable path for AI, which is actually the path of software engineering, which is you build a one-off, and then you build a bunch more one-offs that look like this, okay? And then you actually realize that there's a bunch of tools and utilities that you've built that will make it easier to build the next one-off, and you build a library, okay? And then you realize that the control flow and the data flow actually are pretty similar in these things, and so you build a kind of a backplane or a platform, and you attach these utilities to it as necessary. And then you stop actually programming the utilities, you build a little configuration file and a configuration language that tells you which ones to invoke. And then eventually, as you make that configuration language more complicated, you build a graphical user interface to allow people to manipulate to configure the system, right, using that GUI rather than directly writing in that configuration language. And then you build a wizard to help people do that configuration. And then finally, you build a thing to auto-configure. So I think that's actually a very natural path for AI that we can go through for a lot of things. And so this looks a lot like the original Watson system. We have a bunch of utilities and a platform to support these things. And now that we have this, you can write one of these things in, well, it's no longer somebody's PhD dissertation. It's now something you can write in like 2 days if you're an experienced developer, if you know what you're doing. Here's a system we built, TweetTalk. It actually takes stories, and this is a little plugin you can put into your browser, and it will actually automatically find tweets that are relevant to the news story. This is right after the Charlie Hebdo attack. This is a selection of tweets that came back from the Charlie Hebdo attack thing, automatically done. And this program was built, as I said, probably in about 2 days using that platform, maybe less than 2 days. Here's a program called Read It. What it does is it finds Reddit threads that are relevant to the particular story that you're looking at right now. So whereas Reddit typically goes from Reddit to the news, this is going the other way around, from the news to Reddit, okay? Does that make sense to everybody? It's kind of a cool system. Here's one of the Reddit threads that just sees Charlie at the top, and so it's relevant to this particular horrible incident. We built another version of this that's a little more focused called Stakeholder Tweetback. It looks for tweets, but it looks for tweets from people who are mentioned in the story or who are relevant to the story. So it's not tweets from anybody, it's tweets from people in the story. I'm just going to leave this hanging. You know, if you look at the backside of what we were doing, the front end was kind of interesting, but the back end was always, here's a list of blue links, which is actually what search engines give you now, and it's not really what people want. You don't want 1 million stories. You don't want 1,000 stories. You don't want 10 stories. You want a single story that tells you what you want. Right now, you want something synthesized for you, and we'll get back to that later. So I'm going to shift gears and talk about finding stories in social media. This is the only part of the talk that has anything to do with machine learning. And I'm not really a machine learning person. This is really about using machine learning. So here's a system called Attitude Buzz that actually, so this is kind of a cool or not. Hello. Yes. Thank you. Okay. So excellent. So this is Attitude Buzz. I'm sorry about the graphics. We're not really great graphics. This is Jason Cohen, my student Jason Cohen. This is a program that kind of looks for the attitudes towards gays and lesbians based on the tweets in a neighborhood. So this is basically gay-friendly versus homophobic. Blue is gay-friendly, you know, lighter blue is less gay-friendly, yellow is not gay-friendly, gray is we don't have enough data, red is really unfriendly, okay? And this is done by looking at the tweets from the neighborhood. We were and you can fuck around with this if you want to. I'm sorry?
The White House.
I understand. We don't get that level of. So here's Chicago, for instance. It's a relatively gay-friendly town. Here is.
The generation location for where the author lives.
So here's the story. I mean, so we can make it fancy. So this is actually the Bay Area, which is mostly gay-friendly, except it's not so gay-friendly over here, which is Oakland, and that. I mean, it corresponds to our anecdotal theories of the world, of sort of the pop sociology. Whether that's true, I can't say. Here's Jacksonville, Florida. So you asked a really important question. So Jacksonville, Florida, again, is, you know, a less gay-friendly area of the country. The question is it people who live there, or are they just passing through? So if we wanted to be more accurate, we'd start doing things like how often are they tweeting there between, you know, 6 p.m. and 10 p.m. or in the middle of the night if they're the president and they've gotten up and they're cranky, you know. But you know what I'm saying? In other words, that's correct. In fact, by the way, the real critical thing here is how do you find the labeled data? And so a lot of what we do in our lab is we look for like cheap methods. And so we actually just said, you know, you can go. And by the way, in the specifics, if you look at any given tweet, this thing has very low accuracy. But in the aggregate, it's pretty good at identifying neighborhoods. And the particular thing that we're looking for, so we were inspired by a website called nohomophobes.com, and all it does is it lists uses of sort of derogatory terms for gays and lesbians, like, you know, queer, and maybe terms that I'm not going to say that are that might be mentioned. It's actually Twitter being, you know, like the internet in general, but maybe more so. You know, it's a pretty horrific thing to see. If you see how many of these terms will cross through the thing every day, it'll be tens of thousands or more. But, you know, they're not all actually homophobic because it depends on the context. So queer, for example, is a word that gay people have reclaimed and actually use themselves to talk about themselves. So it doesn't really have the same sting, maybe, that it might have had. But it depends who's using it and what they're saying with it. So what the system needed to do was learn the modulators, the other words that would show up in the context to tell you whether this was a homophobic or not a homophobic use of this term. Does that make sense? And the way we did that is we assumed that, so it's actually much worse than you're imagining. We actually just assumed that things that came from gay-friendly neighborhoods were positive. And we made no assumptions about the other neighborhoods. And we used a sort of a one-sided learner, and you can find these things and buy them for $1.50 at the Apple store. And the question is, does it predict gay-friendly neighborhoods that we don't know about? And the answer is yes, it does. Okay, so at that level, it's reasonably accurate. So it's kind of a cool system. I think we want to apply. We could probably apply this to other social attitudes. I mean, racism is an obvious thing to think about, and there are a variety of other things that we could build with this. So maybe one lesson is that the great thing about this technology now is it's just that even people like me can do it. I mean, I can't do it, but I can. So this is a system we built called Tweetcast Your Vote to predict who we're going to vote for in the 2012 presidential election. Come on, Sparky. Here we go. So Tweetcast, yes. Come on, Sparky. Yes. Okay, so here it is. Tweetcast Your Vote. And you can fool around with this too if you want to. So the first thing is these are the words on the right that were most predictive of being an Obama voter. And on the left, being an Obama voter. I know. In the 2012 election. Now, these are not the most common words. These are the most predictive, the ones that were most distinctive. I hope that's clear, okay? As a predictive thing. I love that, actually. You know, it's basically profanity and your enemies, I guess, are the two things. If you look at the hashtags and websites, it becomes a lot more kind of understandable. And then you can type anybody in, and this thing is about, for most people, it's about 80 to 85% accurate, which is when you take a machine learning system off the shelf and you don't really, and you do something simple, like here we're using valid words. In other words, there's no depth to the language model we're using at all, and we're just using some standard SPM or something like that. And if you don't tune it, mid-80s is actually what you can get typically, and if you're lucky, and so we do. And so we can put anybody in. Here's Bill Gates. Bill Gates, we believe, voted for Barack Obama, and this is why we think he voted for Barack Obama. And this is probably a reasonable thing. Anybody here tweet? You don't even look. It's not.
4 years ago.
I'm sorry.
I tried this 4 years ago.
That's okay. Even if you can't vote, it can predict who you would have voted for if you could have voted.
Not sure I want to.
It's not always accurate. Don't worry. Okay, we don't have to do it.
Here, I will. M.L. Paulson. Paulsen.
Yes. How often do you tweet?
Not very often.
Yeah, we'll see how it does. Okay. You're safe. No, I'm kidding. I have no idea. Predicted you were going to vote for Obama, and it predicted because of the word register, for instance. That kind of makes sense. The word faster. That's what I love about statistics. I mean, who knows?
What did you use as a training set?
What did we use as a training set? So this is really good because Sean went to give a talk about this at a conference, and the guy before him was trying to do something similar, and he actually said, of course, but people don't tell you who they're going to vote for. Yes, they do. People tell you who they're going to vote for all the time. So the actual thing that we did was we actually looked for people saying, I'm going to vote for Barack Obama, or I'm going to vote for Mitt Romney, or I love Barack Obama, or something like that. And as natural language processing goes, I think we would call this regular expression pattern matching. Okay? And so we look for those things, and we use those as the tags. The amazing thing is, up to the point that we did this, as far as we can tell, no one had ever done that before. In other words, people would look at expressions of opinion or choice or attitude on social media, and then if they were marketing people, they would drill down. Why do you feel that way? Why do you like your Nike sneakers? Okay? Or they might say, in terms of machine learning, in terms of preference prediction, they would say, if I follow Nike, or I like Nike, or I thumbs up Nike, then I'll use that as a signal for a predictive, or if I buy Nike sneakers, if I have the transaction data, I'll use that as a signal. Yes?
Have you tried to clean up from bots?
Yeah, I mean, we could actually, if we got serious about this, of course. The main thing I'm trying to say is that nobody had actually used direct linguistic expressions of preference, choice, or attitude as the tag for a machine learning system. I have filed for a patent on this. And I'll see if I get it, but if I get it, I think that's going to be kind of fun, actually. Thank you. I mean, what I should say is Northwestern University has filed a patent for this, is what I should say. So it's pretty cool. I mean, just because it's so simple.
I'll bet you will.
I think it would be great. I mean, I would love that. Oh, I'm sorry. I made a mistake. I should have. Let me go back and do one thing, which is kind of fun here. Come on. This is, because we're an electrical engineering and computer science department, we have the best quality equipment here. So the dirty little secret of machine learning is that nearest neighbor is never the best algorithm, but it's almost always the top tranche of methods, and it's not too far off the leader, which is interesting, actually. And he had a whole discussion about that for image captioning. It was a fascinating thing. What he did is he took a lot of images off the internet that his image captioning thing, nearest neighbor image captioning thing did, and then he ordered them by caption, and he did a slideshow of the images. And here's what it was. A dog on a beach, 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 the Eiffel Tower, the Eiffel Tower, the Eiffel Tower, the Eiffel Tower, grandma, 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 a sunset, I mean, in other words, you think to yourself that there's 3 billion photos on the web, there are like 3,000 photos on the web. That's this. Okay? Everybody takes pictures of exactly the same shit. Okay? So, what he said was, he said, I hate cheating. I went up to him afterwards and I said, I love cheating. But you have to know when you're cheating. And what I mean by that is, we should take, you should make use of every constraint that you can find to solve the problem, but you need to be aware that you're taking advantage of that constraint. You can't do it implicitly because then you don't really know what you're doing. You know what I'm saying? Does that make sense? I mean, keep it simple. So this system was kind of cool. We did an invert version. This doesn't really matter. So this is how this technology. I'm going to tell you how these programs work. Okay, they're completely trivial programs. Okay, what you need to do is find some indicator of preference or choice on a social media system. We use Twitter because it's open. Facebook would be better. Okay, you need to find people who express that preference. You need to find some of their documents on the system. You need to mush them. You concatenate them into a single document. You need to label them by that interest or that attitude or whatever. You need to find a nearest neighbor machine to use. This is text processing. What do you need as a nearest neighbor machine? I know an off-the-shelf search engine would be just fine. Elasticsearch for Lucene, okay? Throw the documents into Elasticsearch, indexed by this thing, and do that for, I don't know, as many stuff as 5,000 people or 1,000 people or whatever, okay? And then when new comes in, get 200 of their tweets, mush them into a document, throw them into Lucene. Lucene automatically finds the closest matching documents. It does nearest neighbor for you. You pull back the actual labels that you have on it. So I had a high school student this summer from New Trier. He was 15 years old. He built this thing this summer in 8 weeks. He was a pretty good Python programmer, but he knew nothing about anything else. I mean, he was a really smart kid, don't get me wrong, but he knew nothing about preference prediction or AI. And he didn't think this was going to work. And I said, I don't know, let's try it. So he gathered a bunch of data about Northwestern clubs and extracurricular activities, okay, and people who follow or like them that we thought might actually be students. And he built this system. We haven't really tested it yet, but one way to test a system like this is to take people whose preferences you think you know, okay? And so Hillary Clinton, the system brought back NU Democrats, college Republicans, and Northwestern political union. That makes sense to me. For Julia Louis-Dreyfus, Elaine, as many of you know on Seinfeld, who was a Northwestern alum. NU Democrats, Jewish Theater Ensemble, Northwestern Flipside, which is a satirical magazine here. Lipstick Theater, which is a women's theater group. The Dolphin Show, which is a musical theater group here. My daughter was the producer of the Dolphin Show in her senior year at Northwestern. Pretty cool. Student Alumni Alliance. And then for Bill Gates, Unite for Sight, which is a global health organization here at Northwestern. The College Republicans. The Northwestern Crew. I have no idea why. Engineers for a Sustainable World, which makes sense. Alpha Chi Omega, which turns out to be a sorority. And then Design for America. So, I don't know if this is going to be good or not. I'd love to get this thing built out, and we'll see if students use it. So what I'm trying to say is it's relatively trivial to engineer a system like this at this point. I mean, this is the great thing about computer science. These things have been turned into, computer science is about abstracting things and building the abstraction. And now the abstraction has been built. You can build an application on top of it. This program is 200 lines of glue code. Okay, that's it. Okay, so that was a little detour into kind of things we're doing in the lab. I want to get to the punchline. So this work actually started before that last set of work I showed you, but if I showed you this first, I would never get past it because it's really the best stuff I have ever done, so we have to leave it for the end. The obvious point of gathering and analyzing data is to present it to people in a way that they can understand and make use of. And that's why visualization became such a hot topic in computer science. And a lot of visualization, like Tableau is almost their motto kind of is, we're going to tell the story in your data through visualization. But we actually tell the story in your data by telling a story, a natural language story, okay, that actually does tell a story in your data. And this is by mission statement for the company. Narrative Science, it is not the company's mission statement. My mission statement is making the world's data meaningful to people through stories. And if I were going to be googly, I would say making all the world's data meaningful to people through stories. But they have another. This is not their mission statement. This is my mission statement. Okay. And the punchline is we take data like these. So these are the these came from a hockey game, the Rio Grande Valley Killer Bees. Okay. And we take these data and we turn it into a story like this. The Rio Grande Valley Killer Bees were firing all civilians against Laredo Bucks, and when the final buzzer sounded, Killer Bees emerged with a 6-3 win. Zach Pearson was all over the ice for Rio Grande Valley. He tallied 2 goals and 1 assist in the win. Pearson scored the first of his 2 goals at 5 points. Blah, blah, blah. It's not a bad story, actually. It's a pretty good story. We do business stories. So we take data like these, And we write stories like these. So we do quarterly earnings previews for Forbes.com. Every quarter we write these stories for them. Apple, or those Home Depot, I guess. We do sector reporting, so we write stories like these. These are very, I think this is an obvious application. You know, the healthcare sector underperformed the market early trading on Thursday. You know, so far the Dow rose blah, the Nasdaq rose blah. You know, human beings actually spend their time writing this stuff, but there's really no reason for them to do so. Here's the thing about Merck. Why stories? Okay, well, we could show you these data, and if you actually knew what you were doing, you would say like, oh, I get it. That would be if you were actually an accountant or you understood business. Or I could show you this graph. Okay, and here we have a graph. On the bottom we have gross profit, on the top we have sales. What's the story in this data? These data.
Grows.
Huh?
Grows.
It grows. That turns out not to be the story. What?
Profits growing more.
That's correct. That's the story. The story actually is this. Sales have increased. There's been a steady decrease in margins, which should be a cause for concern. The answer is yes. Profit and revenue and profit are both going up, but profit is going up slower than revenue. And if you're in a business, that sucks. Okay. So in fact, the story looks great, but it's not great. So the idea here is that stories pick out, connect, and summarize the critical aspects of the situation. They explain what's going on. They provide context. They make data meaningful. The first prototype was built at Northwestern. And let me show it to you. This is actually the second prototype. The first prototype we actually built in a class. The second prototype we built was built in probably early 2010. After this baseball game was played, this is the box score, the line score, and the play-by-play data of the Philadelphia Phillies playing the New York Yankees in November of 2009. And we take these data and we write this story. Matsui drives in 6 to lift Yankees to victory over Phillies. Hideki Matsui put the New York Yankees on his back Wednesday and led them to a 73 win over the Philadelphia Phillies at Yankee Stadium. Matsui went 3-4 at the plate and drove in 6 Yankees runners. Matsui homered in the second inning, scoring Alex Rodriguez, singled in the third inning, scoring Johnny Damon and Derek Jeter, and doubled in the fifth inning, scoring Rodriguez and Mark Teixeira. Andy Pettitte got the win for New York. He allowed 3 runs over 5 2/3 innings. Pettitte struck out 3, gave up 5 walks, and surrendered 4 hits. And since we know that Hideki Matsui is the most important player in this game, we go out and we find a photo of Hideki Matsui. What's wrong with that photo? There's something wrong with that photo, it turns out. That's exactly right. This is Hideki Matsui playing for the Tampa Bay Rays. So we got the wrong. We didn't get the right photo, but we didn't put enough constraints on the image, so we didn't. We should have actually said the name of the player and the name of the team, and we didn't do that. We just said the name of the player to get the image. So next time, you know. Of course, I want you to know that I had no way of noticing that. Somebody had to point it out to me. It's like, how could I? I was just lucky. I was just happy it wasn't the Red Sox uniform. You know, I thought that would be anything. Okay. So this is a pretty good story. It's about as good as what's called the AP short recap that comes out after a game is played. And so that's when we decided to start Now to Science. This is not really a machine learning system, and we'll talk a little bit about what it is and maybe why I think it isn't a machine learning system. I mean, for one thing, because there's a relatively complicated internal structure that this thing has to build. Okay, so one thing to say about machine learning right now is machine learning is very good at kind of featural representations. It's not so good at relational representation. It's not so good at structure. It's very good at like individual features or even aggregates of individual features. It's not so good at what we might think of as emergent properties or connected properties of things that can't be represented so easily in propositional logic. And you can see that a little bit if you think about what things people are using neural nets for right now. They're using them for categorization much more than they're using them for generation. Okay? They're not using them to write programs. So I want you to try and imagine writing a machine learning program that can learn how to program. Okay? It's not going to look like the current generation of machine learning programs. All right? And we can talk more about why that is. We got this thing from the XKCD, which told us that we had a ride. A weighted random number generator. Just we said we got the numbers. Let's use it in that. It's all split counted. I was excited that it was a weighted random number generator. It couldn't just be a random number generator. This is a very simplified thing, but the bottom line is the data come in. We have a bunch of I should say something about how we have to. We'll talk about it in a second. So we have to actually run some analytics over the data, and then we have to run some results some tests over the results of those analytics. Okay, and that produces basically a characterization of the facts in kind of narratively interesting terms. And what do I mean by that? What I mean is, if I look at a story, I might say this was a come from behind victory. And when I say to you come from behind victory, that's a very resonant term. You understand right away what the story was about. I hope that makes sense. Then we have to render it. We have to actually organize that information and render it into language. It's not a trivial program. I mean, it's a pretty big program. These are the things I'm talking about, like comeback or a fade or low-hanging fruit. These are extremely. There are data patterns in the world that people give names to, and those names are very meaningful to them, and they capture a lot of information in a very short, very succinct way. So I'm going to give you another example. So suppose I'm telling a story about revenue, and the top line revenue of a company is flat for a quarter. So now I'm going to drill down and look at the components. For example, the product lines that the company sells or the divisions the company has. And it might be that all of those are flat too. What's the theme there? Nothing happened. On the other hand, the top line might be flat because something went up and something else went down and they canceled each other out. That's a completely different story. The phrase in English for that would be, it was a wash. Okay, when you hear a phrase like that, when I hear a phrase like that, I go, okay, that's really important. It could be something went up a lot and a whole bunch of things went down a little and fucked it up. Okay, that's a different story. That's held back. If you wanted to be romantic, it's death by 1,000 cuts. Okay? Now, we don't necessarily say it was death by 1,000 cuts. I mean, we're generating business stories, we're not generating pulp fiction. You know what I mean? So, but you can call it death by 1,000 cuts if you wanted to be. That's what the theme is called. Okay? Like the Hideki Matsui story was strong victory based on a heroic individual effort. That's the theme there for the Matsui story. Okay? So of course we can't write all the stories. I mean, the whole point of this was to actually people can't write all the stories that would be written in the world. Actually, we can't even configure this system. And so a lot of what we're doing right now, and this is related to the path for AI I talked to you about before, is at one level, this thing is inherently scalable. I mean, once we actually can figure out how to write stories for a given domain, we can churn those stories out indefinitely, okay? But horizontal scalability, which is to say I can move to another content vertical and actually quickly configure the system, that's really what we're focused on, okay? And so a lot of what we work at the company now is to have a theory of story specifications, a configurable platform, and authoring environment so that we can give this to you and you can use it, okay? And we're not there yet. We have tools that we can use internally. I would say within a year, we hope to have tools that we can release to, I mean, what are we aiming for? So it's not going to be trivial. Maybe it'll be as hard as using Microsoft Excel, which is not trivial. I mean, if you can use it, you don't have to be a programmer to use Excel, but you can't, it's not trivial either. You know what I'm saying? It's a non-trivial thing to be able to do it. So that's the level of hardness we're looking towards. I should say a little bit, we do Big Ten softball stories. At one point, our program was the world's most prolific author of women's collegiate softball stories. Because, I mean, we did Big Ten football, but there's a lot of money in Big Ten football. You need a program to do that, But women's softball, actually, the Daily Northwestern will not necessarily write up every softball game that our team plays in. But, it's a big world, and somewhere in the world there are people who are avid to read stories about women's collegiate softball in the Midwestern United States. That might be, for example, people on the team and their families, or does that make sense to everybody? So that's kind of the model. We do civic data. We did a thing with ProPublica where they helped us collate data from the Department of Education on around 52,000 schools in the United States. And we wrote stories like this. Here's a story for Evanston Township High School. And it's not, breathless prose, but it tells the story. The story is basically that student achievement versus the socioeconomic socioeconomics of the student population, and then kind of benchmarking that against other schools in nearby, basically. That's kind of it's the story you think you should write. We did social media data. This is an experiment we did in the Republican primaries 4 years ago. Newt Gingrich gains attention with hot button topics, taxes, character issues. So we start from structured data. So we do the same thing everybody else does. We're going to take Twitter data and structure it somehow, and then we're going to actually tell a story based on those structured data. I like this. This is bullshit. I mean, this is like boring. Newt Gingrich received the largest increase in tweets about him today. Mazel tov. Okay. Here's the one that's interesting. While the overall tone of the Gingrich tweets is positive, public opinion regarding the candidate and character issues is trending negatively. In particular, Mama Vicker says someone needs to put the blood on suspicious character to a photo montage of Newt Gingrich, and then there's this lovely hashtag here. Okay. So I want to say something about this. Our program does not understand this tweet. Okay. I mean, it knows what it wrote, but it doesn't know this. What it knows is I'm looking for the most negative tweet I can find on this topic about Newt Gingrich, and it sticks it there. And if the categorizer is, so it usually works because the internet is very big, and if you say I want the most negative, does that make sense to people? It doesn't understand that tweet. We can go on. These are the data from a large fast food franchise operation, point of sales data. The people who manage these restaurants are very busy, and they often didn't go to college. How can we tell them a story about these data? This is the world's most boring story. Unless this is your restaurant, in which case actually it's an extremely interesting story. Okay. Bringing the store's daily sales of Reuben sandwiches up to the same level as the cost without about $566 more profit each month. Over the year, that's an extra $6,800. The store only needs to sell 6 more units per day to accomplish this. Okay? This is like, just do this and we'll, gain weight or lose weight or whatever you're trying to do. It's the, this is the low-hanging fruit theme, by the way. What's one simple thing this guy can do to make his life better? Educational data. Actually, this is something we just released, which is fun. So we actually have plugins for Click, for Power BI, for Tableau, and for SAP Numera. So if you're going to use one of those systems to visualize some data, and you download our plugin, we will automatically write a narrative to associated with the visualization you're producing, and show that to you as well. So this is actually a narration, or we have to go to the extended caption in some sense that automatically pertains to this thing that we wrote, and we do this, as I say, for Power BI and for Click. It's interesting because when we get the data that way through a visualization system, we don't necessarily have all the metadata that we would like about the data, so the stories become a little bit harder to tell. And so we have this process we call semantic enrichment, where we ask the user a few questions if they wish to tell us. Here's a good example of a question we ask the user. Is up good? Okay? Because if we know that up is good, instead of saying increased, we can say improve. All right? So that increases the story. This is the main sports application that we still do. It's a company called Game Changer. They have a smartphone scoring app for youth sports, particularly Little League baseball and actually basketball, I think now too. And if a parent or a coach scores the data and sends it to Game Changer, which is it's just an app, so that's easy. We get the data and we write the story. We write probably 10 million Little League stories every year, which are read by proud parents and yeah. You have a question?
Yeah. Well,
oh, I just want to say that so this is it's a cool application, although it doesn't really make a lot of money, but it's fun. Yeah.
so maybe can you say a little bit about how you're evaluating the quality of these stories?
Yeah, this is a really big, really hard question, and originally when we did this, so we have some internal metrics that we can, that are boring. I mean, readability metrics and things like that we do. The original thing that got us going was we actually had a sports reporter at the Toronto Star actually took apart a story that we wrote about a ball game and a story that he wrote about the same ball game and did a kind of a sentence-by-sentence comparison. And he thought our story was very comparable, if not better. But, I mean, you raise a very profound question about how to do the evaluation. I can tell you that so far when we put these things out in the world, we have customers. We don't really do a lot of media that much anymore because media turned out to be not the right market for us. But we had customers who actually told their customers that they were using automatically written stories, and we had customers who did not tell their stories that they were using automatically written stories. And I don't think they ever tell the difference. There are people who have done studies with data, with output of our program, our systems, and actually we have competitors now on their systems to see whether people can tell the difference. And the answer is no, they cannot tell the difference. A thing that we're doing now, which I think is very exciting, is we're adding auditability to this. So I think what's actually, there's a thing where started by talking about saying that these systems have an editorial bias in them. And I think one thing that's kind of exciting about running these things automatically is that you can begin to ask yourself, can I see what that editorial slant is? Can I look in the program and see parameters that reflect that? You can't look inside of a person's head necessarily to understand those things, A thing that we're doing now is that in the upcoming version of the system, when you click on a sentence, it'll tell you, here's why I wrote that sentence. Okay? Here are the rules that fired. Here's the thresholds that got met. Here are the things that didn't get met. And here are the actual analytics that I ran. And finally, here's the data that I used that actually generated the story. So you can interrogate the story sentence by sentence if you want to say why it told you that story the way it did. So I think that might improve trust. That I think is going to be very important for trust going forward. So this was kind of cool. We got from XKCD. So that was XKCD was like, I don't know, 6 years ago or 5 years ago, and we had this thing in the New Yorker. Did your dad or a computer algorithm like this by Jeremy Greenfield. Benner had a good game to play for the Hamilton A's Sportsini. Benner went 2-3, drove in one, scored 1 run. Sidney went 30 and doubled in the 5th inning. This was written by a computer algorithm from Narrative Science, a company your dad thinks you might want to work for, which is why he sends you every article about how innovative the AI-powered language generation platform is, even though it is literally the opposite of what you do and against everything you believe. So I hope it's not, but I felt that there was some progress in going from XKCD to the New Yorker in terms of our visibility in the world. This is what I think of as the future. I don't know that I answered your question very well. I think it's a really hard problem. If you can think of something, let me know. Yes.
These terms of phrase define the style.
Yeah.
You discover them, or you.
So we don't use machine learning. They're kind of. We thought about that. We thought about the idea. For instance, could we write the story in the style of X, especially where X is deceased, for example, and maybe we wouldn't get into. Could we mine their text and essentially do that? We haven't done that. I actually think style, in some ways, is more a matter of the mode of explanation and less a matter of the. So I'm interested in things like this, like what kind of explanation are you looking for? Are you looking for in a sports story? Do you want to know who was heroic and glorious, or do you want to know who screwed up? It's like a lot of people love stories about who screwed up, and if you want, we can make the story. We can make the system sort of tend to want to tell you stories about people who screwed up. So stylistically, I think of that as kind of a more interesting thing. The answer is no, we don't really mind stuff right now. This is kind of where we're going. I'm here to answer questions now. I want to say one thing about the future of work. This is the future of work. I actually got to the conference and I said this: craft beer is the future of work. Okay, and I'm going to tell you why craft beer is the future of work. And this is actually because the issue came up of automation and what does it mean for the future. I think anything that can be automated will be automated. And computer science is about automation. That's what we do. And we're going to automate ourselves too. Teaching will be automated. Research will be automated. So what is there left to do? There's always going to be this residual of stuff that's not automated. But what do people buy? You could buy automated beer. That's like Budweiser. You can buy commodity stuff. Or you can say, no, I don't want that. I want beer from a craft brewery. And you will notice actually that this has become a big deal in the United States. And there's actually a lot of money to be made, and a lot of younger people are actually saying, my future in life is I want to be a brewer. I want to build a craft brewery. And when you build a craft, and there's several in Evanston now, for example. And when you go to a craft brewery and you buy a beer, what are you buying? Are you buying a beer? You're buying the experience. You're buying the experience of being there where it was created, the experience of interacting with the people who created it, of listening to them tell you why they make it, why they love making it, how they made this particular one, okay? So the experience becomes much more individuated on the whole human process of the production and less on the actual thing at the end. There's a sense in which things are becoming decommodified now, and dehumanized. Right, and I think this is actually a good path forward for the economy. That the stuff that can be automated and commodified will be automated and commodified. But the richer we become, and the more things are automated and commodified, in some sense, the more money there will be to do this, the more we can actually afford to buy things that are not that way. So right now, we don't have to buy beer from a can that was made in a factory 500 miles away. We can buy it down the street where it was made down the street and talk to the person who made it. Okay? You don't have to buy clothes, like this. You can actually talk to the person who will make your clothes. You don't have to buy furniture that looks like this, which, by the way, looks terrible. You can actually go talk to a guy who loves making furniture, and she will tell you why she loves making the piece of furniture that you're buying from her. So I actually see a pretty positive future in crafts for the whole economy, but, it's my job to be optimistic. So,
But your stuff will be generating will be descriptions.
So I actually gave this talk, when I gave this talk to someone else, somebody said, yes, but there's an AI craft brewery that's heading to it. I'm supposed to be out here now?
Maybe I got moved and I missed it somehow. I'm guessing you think you have this room for a while.
No, I think we're done.
Oh, fine. Yeah. I see. Oh, okay. Sorry. We'll be out
Oh,
here.
okay. So, anyway, this is what I'm hoping the future will be. Thank you all, my colleagues, especially Chris Hammond, our students, especially Nick Allen, Miriam Green, Jason Cohen, Francisco Jacobelli, Jawei Liu, Patrick Cowan, Sean O'Banion, John Templin, and Earl Wagner. Our funders, especially the Knight Foundation, the National Science Foundation, and Google, and of course, Matter Science for making it real. Thank you very much.